In this lesson, we'll look at factors that affect the strength of electric forces. We'll talk about how charges affect electric forces, how the distance between charged objects affect electric forces. We'll learn about Coulomb's law, and we'll talk about the inverse square law and how it applies to electric force. We know that opposite electrical charges attract each other with an electrical force. If the charge is small, then the force attracting the objects together is small. If the charge of the objects is large, then the force attracting the objects together is also large. It works the same way if they're like charges and they're being repelled by electric force. Small charges have small electric forces and large charges have large electric forces. Distance between the charged objects has a similar effect on electric force. If there's a large distance between charged objects, then they have a small electrical force either attracting or repelling them. But if the objects are close together, then the electrical force attracting or repelling them is much larger. The electrical forces between charged objects are described by Coulomb's law. The equation for Coulomb's law contains all of the factors we've been talking about. The F is for the electrical force between charged objects. The force is measured in newtons like other forces in physics. Charge is represented by the variable Q, and because we have two objects, we have Q1 and Q2. The unit for electrical charge is the Coulomb, which is abbreviated with a capital letter C. The distance between the objects is represented by the letter R for radius, and the radius is measured in meters. Notice that the radius is squared. We'll see in a moment why the squared radius is very important. The last part of the equation is the letter K. K is a constant called the Coulomb constant, and its value is 8.99 times 10 to the 9th Newton meters squared per Coulomb squared. You'll learn how to solve problems using the Coulomb's law equation in a different lesson. For now, let's just look at the parts of it. You can see from the equation that the Q's, the charges, are on the top part of the fraction. So if you have a big charge, big Q, you're going to have a big force. The distance between the two objects, represented by R, is on the bottom of the fraction. That means that if you have a large distance between the two objects, you're going to have a small force. Notice that the distance on the bottom of the fraction, the R, is squared in the Coulomb's law equation. That means that the distance has a very strong effect on the amount of force. As the distance increases, the force gets much smaller quickly. Or as the distance gets closer, the force gets much bigger quickly. This is what's called an inverse square law. It's inverse because it's on the bottom of the fraction, and it's square because of the exponent 2, it's being squared. Another example of this that's easy to picture is with light. If you shine a light bulb, it shines a certain amount of light on a surface that's 1 meter away. If you move the object 2 meters away, now it's twice as far away, but the light is spread out over 4 times as much area. So when you double the distance, you decrease the amount of light on each part of the surface by a factor of 4. If you triple the distance and go 3 meters, now the light's shining over 9 times as much area as it was in the first place. So you can see that the amount of light on each area is getting smaller much faster. We're only going doubling or tripling the distance, but the amount of light is going down to a fourth or a ninth. Same thing with the electrical force. If you double the distance between the two charged objects, the force becomes only a quarter of what it was before. Or if you cut the distance between the two objects in half, the force becomes 4 times as much as it was before. That's the inverse square law. In this lesson, we saw that increasing the charge increases the electrical force. We saw that placing charged objects closer also increases the electric force, but putting them farther apart decreases the force. We looked at the Coulomb's law equation, which describes how the electrical force can be found between two charged objects, and we talked about the inverse square law, which shows that the electrical force is proportional to the square of the distance, which means that the electrical force increases or decreases quickly when the distance changes.